All right, let's try this. We'll slow it down. Surely I am on a 0.75 speed. So in your binder, you have this Angle Proofs guide. That's what we're going to use to guide us through the first six. So it's kind of like a multiple choice, just like in that last one. So we're going to take these first six together as one video, and then the next one is another video. All right, let's start here and hold with me on my explanations as I go through them, all right? So, number one, angle PQR is a right angle. It's a right angle that's given to me. And now we're saying that the measurement of this angle is equal to 90 degrees. That is just definition of a right angle. Make sure you are not abbreviating. I'm abbreviating for the sense of TV, but you are not. And now if you look at this, it says angle PQS plus angle SQR is equal to PQR. That's the angle addition postulate. And then on number 4, we have this measure is equal here. So everything's the same except this. So all I'm doing in place of the measurement of angle PQR, I'm substituting in 90 degrees. So that's substitution. And now I'm saying that angle PQS is equal and angle SQR are complementary. So that is definition of complementary angles. Complementary angles. All right. Okay. Number two. Go ahead and pause it and then see if we get the same thing. All right. So number 1, I hope you got given. You'll notice that the only thing added to number 2 was the M, and then it went down to equal. So now we're talking about numbers, which is definition of congruence. Angle 1 and 2 form a linear pair. That is given to me. And now it says, okay, so yeah, we'll talk about this in a second. But we go from angle 1 and 2 form a linear pair to angle 1 and angle 2 are supplementary. That is textbook definition of the supplement theorem. And I want you to highlight that. Okay, that is going from a linear pair, now they're supplementary. And now I can say that the measurement of angle 1 plus the measurement of angle 2 is equal to 180 degrees. That is definition of supplementary angles. So notice the difference between the definition of supplementary angles. Definition of supplementary angles is talking algebraically how the measurements equal 180. But supplement theorem says that if they're a linear pair, then they're supplementary. That's supplement theorem. Definition of supplementary angles gives you that equality statement. Okay. All right, I'm getting something on my computer. And then part 6 is substitution, because all I'm doing here is I'm substituting the measurement of angle 2 for 3. So that's substitution. And then angle 1 and angle 3 are supplementary. That is the definition of supplementary angles because it's biconditional. I can go from here to here, or I can go from here to here. So that's definition of supplementary angles. All right, go ahead and pause me for number 3, and then come back and we'll take a look at that one. All right, now you're back. Okay, so number 1 is given. That's a given statement. And then angle 1 and angle 2 are complementary. That is textbook complement theorem, because we go from forming a right angle to saying they're complementary. Angle 1 plus angle 3 is 90 degrees. That's given to me. And then angle 1 and angle 3 are complementary. That's a definition of complementary angles. Again, you'll notice here's the measurement. Now I'm saying that they're complementary, and this can go back and forth, right? Because it's biconditional. And then how are they getting that angle 2 is now congruent to angle 3? So this is kind of that one that looks like transitive property and congruency statement all wrapped into one, and that's called the congruent complement theorem. Congruent complement theorem. because we're saying angle 1 and 2 are complementary, and angle 1 and angle 3 are complementary. So I'm taking out the middleman of 1 and 1 and saying that now the angle 2 is congruent to angle 3. So that's that transitive property kind of rolled into one. All right, number 4, take a shot at that one and come back. All right, now if we look at number 4, and again, you can use your cheat sheet with you, right? Number 1 is given. BE bisects angle ABD, and now I can say that ABE is congruent to EBD, and that's just definition of angle bisector. And now BD bisects EBC, that's given statement. And now I'm saying that EBD is congruent to DBC, that's definition of angle bisector. And now we're getting that angle ABE is congruent to angle DBC, and that's the transitive property here. So remember that transitive property. If you look back here, here's angle ABE congruent to angle EBD. Angle EBD is congruent to angle DBC, and now we're taking out that middleman and saying that angle ABE is congruent to angle DBC. That's that transitive property. All right, number 5, let's take a look. Pause it, come back. All right, number 5, 1 is given statement. So RSU is congruent to VST. Remember, I'm making those markings in there. And now all I've done is I've put the measurement in and taken off that congruency. So that's where I'm saying the definition of congruence. And then angle RSU plus USV is equal to RSV. That's angle addition postulate. And VST plus USV is equal to UST. Again, that's angle, RSU, I think I messed up. USV is congruent to RSV. Very good. And then VST is congruent to USV, which is equal to UST. Yeah, angle addition postulate. And now I'm saying that angle RSU plus angle USV is equal to angle UST. So I can go back up here and I can substitute the measure of VST, and I'm putting in the measurement of angle RSU. So that's going to be substitution property. And now I have on angle, or excuse me, number 6 is going to be angle RSV is congruent to angle UST, and that is going to be, no, that's not transitive statement. Yes, it is. USV, that is, hang on, I know you probably catch it at home. Oh, yeah, duh, transitive, sorry, here I am. Okay, so RSV is equal to this, all of this, and all of this is equal to angle, measurement of angle UST. So I'm taking out that middleman and saying that the measurement of RSV is congruent to the measurement of UST. That's transitive property. And now I'm adding back on that congruence, so definition of congruence. Took me a while on that one. I guess I can use my cheat sheet. All right, so number 6, here we go. Let's take a look at number 6. Oh, angle 1 and 2 are complementary. That's given to me. Oh, did you pause? Sorry, pause. Okay. All right, now let's see what we got. So, given statement, 3 and 4, that's given. The measurement of angle 1 plus angle 2 is 90 degrees. That's definition of complementary angles. Angle 3 plus angle 4 is 90 degrees. Again, that's definition of complementary angles. Anytime it talks about the algebra part, the numbers part, that's just definition. Angle 2 is congruent to angle 3. That's the vertical angle theorem. And then again, look at that. I'm just adding on the measurement, taking away the congruency mark. So that's definition of congruence. All right, so now I have the measure of angle 1 plus angle 2 is equal to the measure of angle 3 plus angle 4. So I'm taking out that middleman. So I am saying that is my transitive statement. I'm saying angle 1 and 2 is 90, angle 3 and angle 4 is 90. So now I can take out that 90 and I get transitive property. Okay? Everything looks the same except the measurement of angle 2 and the measurement of angle 3. But here I'm saying that the measurement of angle 2 is equal to the measurement of angle 3. So because here I can now use substitution to make that claim. And now if I subtract away the measurement of angle 3 on both of those sides, my subtraction property of equality, I get down here to the angle 1 is now congruent to angle 4, and that's a definition of congruence. All right, aren't these fun? Okay, if you're struggling, remember, I want you to work and I want you to tough it out. So don't be angry because I don't want to spoon feed it to you. I want you to think about it. So the next video, we will do the next couple of problems just like we did last time. Good luck.